Radians and degrees. What are degrees? When we work with angles, we use the measure degrees. Where did the term degree originate? Ancient Babylonian astronomers are credited with inventing the degree measure. They used the 360 measure as the number of degrees in a complete turn, what we would call one rotation. They saw that the stars in the sky showed two kinds of movement. The star would rise and set during the course of one night, moving in arcs centered on the North Star. The ancient Babylonians also noted a change in the position of a given star from night to night of 1/360 of a circle. This would take about a year to complete one revolution. This is believed to how the measure of 360 degrees came about to represent one complete revolutions. Well, what are radians then? Over time, mathematicians started using the term radian when working with circles. If you take a circle and measure the length from the center to the outside of the circle, this measure is called the radius. Using a string, you could measure this distance. Position one piece of the string at the point where the line representing the radius meets the circle. Measure around the circle the same amount, shown in gold. Mark this spot with an X. Shade in this length with a different color. This measure is called the arc length. Now, draw another line from the middle of the circle to the X. The angle that is formed in the middle is 1 radian. Relationships. Here is a formula you should make note of, as it will be important when completing your lesson. The arc length is equal to the radius times the number of radians. Or the radius is equal to the arc length divided by the number of radians. Or the number of radians is equal to the arc length divided by the radius. Again, please make note of this as you will be using it. One complete revolution is 2 pi radians. Now, let's take a look between the relationship between radians and degrees. 2 pi radians is equivalent to 360 degrees. This is an important relationship. 1 radian is 180 degrees divided by pi. Please make note of this. You will need it for your lessons. Degrees to radians. 360 degrees is equal to 2 pi radians. 1 degree is equal to pi divided by 180 radians. Again, an important piece of information. Now, let's take a look at an example to see how we would use this. Determine an exact and an approximate radian measure to the nearest hundredth for an angle of 30 degrees. Where do I start? What does the term exact really mean? A value is written in exact form when numbers are not reduced and rounded. For example, the square root of 29, or the term pi over 6, is an exact form. What then does approximate mean? A value is written in approximate form when decimals are included and you may have rounded the answer. Please make note of this as you will be asked to give your answers in either exact form or approximate form. First of all, to do the conversion, determine the conversion factor, and I've already provided you with these two factors. To convert a degree measure to a radian measure, multiply the degree measure by pi over 180 radians. Multiply by the conversion factor. So 30 degrees would equal 30 times pi divided by 180. Common factor, so 30 times pi over 30 times 6. Eliminate the common factors top and bottom, and we will arrive at the answer, pi over 6. "30 degrees is exactly pi over 6 radians. To find an approximate radian measure, use your calculator. Pi over 6 is approximately equal to 0.52. Conclusion, 30 degrees is exactly pi over 6 radians. Pi over 6 is approximately equal to 0.52. Wherever possible, please express the angle measure in its exact form. Now, let's go from radian measure to degree measure. Let's start with an example. Please determine the degree measure to the nearest tenth for a radian measure of pi over 4. To determine the conversion factor, remember to convert a radian measure to a degree measure, you multiply by the radian measure by 180 divided by pi degrees. Multiply the conversion factor, so we would take pi over 4 times 180 divided by pi, factor out what's common, divide the 4 into 180, and you would get 45 degrees. What then is our conclusion? Pi over 4 radians is exactly 45 degrees. Piece of cake. Here is another example that you can try. Determine the degree measure to the nearest tenth for a radian measure of 5.86. Solution: determine the conversion factor to convert a radian measure to a degree measure by multiplying the radian measure by 180 divided by pi degrees. Now, multiply by the conversion factor. 5.86 equals 5.86 times 180 divided by pi degrees equals 335.8. Now it's your turn. Before continuing to the next video, make sure you've added the key formulas covered in this lesson to your study notes.